Hello everybody, so in this video we will be looking at a lead code problem, queries on a permutation with key. So it is a medium level problem with more dislike than like, but still we are doing it. So the problem statement says that we are given an array queries that only contains positive integer between 1 and m, and we have to process all those queries until the length of the array queries, and we are given certain rules. So what we will do, in the beginning you have to permutate p, we have to create an array p from 1 to m, and we have to return an array. So this problem statement is quite tricky, but in an easy way if I explain this, the problem statement is quite easy. So what we have to do is, we are given m, so let us take or we m or x whatever. So here we created our p array, which is from 1 to m, 1 to 5, and this is our array queries. So what we will do, we will iterate our queries array. So we will start from here I. We see the value of a or queries of I is 3. So we go and traverse this array and we find in array p the value 3 is at index 2. So what we will do, we will delete this value from here and we will move 3 to the front. 3 will come here and we will then shift all this to the right side. So our new p array will become something like this: 3 1 2 4 5 with index 0 1 2 3 4, and we will store this index, the index of the element we deleted and moved to the front, in a separate array, which will be our answer 2. But before continuing with this intuition, we can do this in two ways. In first way, we can use a dequeue, as we have to delete from in between and add at the front. So dequeue is a very good data structure for this. Or there is another way, that is Fenwick tree. So I'll discuss this approach in some other video. In this video we will be doing it with a dequeue, and it is quite easy with dequeue. So what we will do then, so after first step, we increment our I. Now our I goes here and our j again starts from here. So now it will search for 1. It sees that 1 is at this index 1. So what we do, we put 1 here and then we delete this one from here and we move this to here. So our new array, new dequeue will be something like this, with index 0 1 2 3 4. So in the next step we will move forward. Our I goes here. The value of queries of I is 2. So what we will do, we will iterate from here, we go here, then we go here, we see the value 2 is at index number 2. So we add this to our answer array and delete it from here and add 2 here. Now our dequeue becomes something like this: 2 1 3 4 5 with index 0 1 2 3 4. Now our I goes here and it again searches for 1 in the array p. So it is here at index number 1, we add 1 here and then we again move this, and then our loop terminates. So we come out of and we just return this array. And for the first test case, that we have discussed, 3 1 2 1 1 and m is 5, the answer is 2 1 2 1. So that is the same answer we get. Now if we discuss the time complexity of this approach, so for traversing this queries array, we will go order of n. Then for traversing this array, which is formed from this m size, it will be order of m. Then we are adding at the front, that will be order of 1. But the erase method that we will be using its time complexity is order of n plus m, where n is the number of elements deleted and m is the number of elements shifted. That is, shifted here means like we are deleting 3, so these two are shifted towards this side, that is towards right side, these two are shifted. So this is what we have. So for our case, the delete erase method, Rn is 1 because every time we are deleting one element and always we are shifting j elements. So our overall time complexity will be n into m into j. So now let us just code it. So we need a deque. So as we are using a deque, so our space complexity is a big O of n, right? So now we need to fill our deque. So we will go from I1 equal to m I plus plus and deque dot pushback I. Now our size of the q array is q dot n is q dot size, and we need to return a vector, so we'll take a vector answer. Now we will iterate through our q array I less than n I plus plus. Then we have to iterate our deque. So int j equals to 0, j less than m, j plus plus. So if my q of I equals to deque of j, what I'll do, I'll just take a variable value which will store value of deque of j, answer dot push back j, and then I'll erase my element from the deque. Erase deque dot begin plus j, and after that I'll push front. I'll add that value to the front, push front value. That is all, and in the end I'll just have to return my answer. Now let us just run the code. Okay, it is running. Before submitting, so we are also using a big O of n space for this answer array, big O of n here. This loop is running big O of n times, this loop is running big O of m times, this one too, big O of m, and this one is big O of n plus m, but in our case it is big O of j. So now let us just submit. So as you can see, our solution is submitted. So but if we do this question using Fenwick tree, we can reduce all this time complexity to order of big O of n log n. So I'll discuss that approach in another video. Thank you for watching the video, and if you do like the video, then hit the subscribe button.